from Bacillus thuringiensis. The reference is from the Biological Control Journal and operated in the year 2013. The outline is consist of objective, introduction, materials and method, result and discussion, and conclusion. Objective in this study were to develop transgenic P expressing CLY1AC gene and to confirm the expressing CLY1AC gene by molecular analysis and bioassay. Here, scientific names P-Samsadiol and economically very important multi-purpose label is primarily going for food and feed throughout the world. The production and storage of P constrained by diverse groups of insect pests. This limitation can be overcome by transgenic approaches, preferably CLY genes from Bacillus thuringiensis are the most commonly used gene for development of transgenic resistant transgenic crops. Bacillus thuringiensis is a common gram-positive. During sporulation, many Bt strains produce crystal proteins or glyproteins that have insecticidal action, and it has led to their use as insecticide, and more recently to genetically modified crops using Bt genes. Material and method in this study were the first one to develop transgenic P and some develop of insect-resistant transgenic P, and second one molecular analysis that include PCR, RT-PCR, Southern blot, and immunostrip assay. And third one is bioassay that include leaf paint bioassay and insect bioassay. Let's start with contraction of recombinant plasmids. Use TI plasmid from Agrobacterium and insert CLY1AC gene into plasmid. And this slide shows the typical map of transformation vector PG235X CLY1AC. And CLY1AC is resistant insect-resistant gene from Bacillus thuringiensis, and BAR gene is herbicide-resistant plant-selectable marker gene from Streptomyces hygrophobicus, and send recombinant plasmid into Agrobacterium for transfer to expand. Next step is transformation step. First step, seed preparation. Seeds were surface sterilized and imbibed overnight. The next day, embryo was sliced and inoculated with Agrobacterium suspension. After co-cultivation, the egg plant were washed, and subsequently, the egg plant were transferred to induction medium, and finally transferred to selective regeneration medium, and increase concentration of selection agent in order to recover putative transgenic shoots, and for the in vitro grafting. In vitro grafting shoot onto rootstock from etiolated seedling, and the arrow indicates the graft union type with tail and covered with plastic. Finally, we get successfully grafted putative transgenic shoot to analyze it and setting generation zero generation, and use seed of zero generation to setting generation 1 to 4. Next is molecular analysis. Let's start with PCR. DNA was isolated by CTAP method from leaf of transgenic P and was used for PCR program. Primer for HMG I/Y gene. The results were analyzed by electrophoresis. Result of PCR putative transgenic P shown in figure 1. A is multiplex PCR detection of CLY1AC gene and HMG gene in putative transgenic P, and B is PCR detection of bar gene in putative transgenic P. F is marker gene, and positive control is plasmid DNA. Negative control is genomic DNA of non-transgenic P, and water control. In red box is multiplex PCR multiplex PCR of putative transgenic P. The result appear band of CLY1AC gene in pink box, and in green box appear band of HMG gene, and in red box appear band of bar gene. And result of PCR subsequent generation P. Shown in figure 2, A is multiplex PCR detection of CLY1AC gene and HMG gene in subsequent generation 1, 3, and 4 of transgenic P. B is PCR detection of bar gene in subsequent generation of transgenic P. In pink box appear band of CLY1AC gene and HMG gene, and in red box appear band of bar gene. The result indicated of the stable inheritance of introduced transgene to next generation. Step is second dot. DNA was isolated by CTAP methods from leaf of transgenic P, was digested with EcoR1 and separation by electrophoresis, and transferred to positively charged nylon membrane and hybridized with DHG labeled CLY1AC probe. And the results were exposed by X-ray film for 1 hour. The result shown in figure 3. F is marker gene, and positive control is plasmid DNA. Negative control is genomic DNA of non-transgenic P. In green box is a single copy for 2 clones, and red box is 5 copy for 7 clones. The result in pink box appears signal all copy clones of transgenic P. Next step is RT-PCR. RNA was isolated by nucleospin RNA plant kit from leaf of transgenic P, and synthesis cDNA by reverse H-cDNA synthesis kit, and cDNA were used for PCR and analysis by electrophoresis. The result shown in figure 4. M is marker gene, and B is bank and water control. Positive control is plasmid DNA. Negative control is gDNA and cDNA from non-transgenic P, and VT is genomic DNA from VT of generation 0 of transgenic P as a control. Event block is a PCR fragment of T4 generation. The result of in pink box and green box indicated the expression of CRY1AC gene in transgenic P, while absent in the control P. Next step is immunostrip assay. Crude extract extracted by sample extraction buffer fold and transferred into new microcentrifuge tube and BT CRY1AB/1AC immunostrip assay insert into the tube, and signal on the strip was noted after 30 minutes. The result shown in figure 5. Control is crude protein extract from non-transgenic P, and positive control is BT maize. Is crude extract crude protein from BT maize. And in red box is crude protein extract from leaf of transgenic P. The result of immunostrip assay indicated the accumulation of novel protein, and control signal and test signal were observed in transgenic line, while only control signal was observed in non-transgenic P. Next step is leaf PEN-BIO assay. One pair of leaf from transgenic and non-transgenic P. One of the leaf was marked as control, while Prica herbicide solution Bata was applied on upper surface of the outer leaf and was evaluated visually 1 week after application. Result shown in figure 6. A is herbicide-resistant transgenic P, showing no effect, and B is herbicide-susceptible transgenic P, and C herbicide-susceptible non-transgenic P. Next step is insect bioassay. In the first experiment, we used 7 each P, and second experiment used 10 plants each, and used 5 larvae were inoculated each P. The result shown in figure 7. In the aerorated non-transgenic P, resulted in heavy damage and normal growing of larvae. And green arrow is transgenic P. With little feeding damage and survival of larvae. This graph shows larvae mortality about 100% of the first experiment and 85% on second experiment and about 15% on non-transgenic P. Conclusion: transgenic P has been confirmed through molecular analysis and bioassay introduced CRY1AC gene was stable inheritance up to T4 generation, and there is insect resistance. Finally, I would like to thank Assistant Professor Sukanda Shikhan. My seminar, advisor for giving acknowledge and guide, and so thanks associate Professor Dr. Linda Yunchalat, my course coordinator. Thank you for your attention.